is it looks something like this. So initially you have MA moving with speed VA, MB is at rest, but after the collision, you have MA moving at an angle theta A from the x-axis with speed VA prime, and MB moves at an angle theta B with speed VB prime in the opposite y direction, but the same x direction. So part A, the equations are as follows. So in the for the horizontal dimension, the x-axis, momentum in the x-axis is conserved as follows: MA VA initially, because initially it's all horizontal motion, is equal to MA VA prime cosine theta A plus MB VB prime cosine theta B. And the reason we're using the cosine components is that the x-axis is what, well, you take the cosine of this and you get the x component of it, right? Similarly, in the for the y direction, now you have no initial momentum, and that is equal to the y component of A's final momentum, so MA VA prime sine theta A, minus because it is in the opposite y direction, MB VB prime sine theta B. Okay, so these are our two equations, and in part B we solve them. So in part B, we want VB prime and theta B prime. So let's write things down in terms of VB prime. So from equation from P of x, this first equation, part A, we have MB VB prime cosine theta B is equal to MA times VA minus VA prime cosine theta A. Okay, and from the y equation, we have MB VB prime sine theta B is equal to MA VA prime sine theta A. So we're going to call this one, the first one, equation 1, the second one, equation 2. And so the trick here is to divide up the two equations. So we divide 2 by 1. And so what happens is that the MB VB prime VB prime term cancels, and you have sine theta B over cosine theta B which is equal to tan theta B. Right, sine over cosine is tan, is equal to MA times MA times VA prime sine theta A over MA times VA minus VA prime cosine theta A. So the MA's cancel, and so you have VA prime sine theta A over VA minus VA prime cosine theta A is equal to tan theta B. Therefore, theta B is just the arctangent of all of this. So it is arctan. VA prime final speed is 2.1 sine 30, because that's the angle the ball A makes, over VA initial speed 2.8 minus 2.1 cosine 30. And this comes out to be 46.9 degrees, right? And therefore, finally, we have we can plug this back into equation 1, or let's say equation 2. You have MB, that's equation 2, by the way. So MB times VB prime, MB VB prime sine theta B is equal, well, now we know theta B is 46.9. So MB VB prime sine 46.9 is equal to MA VA prime sine theta A. MA is 0.12 kilograms. 0.12 kilograms times VA. It's not times VA, which is, or VA prime, which is 2.1 meters per second, times sine 30 degrees. Therefore, VB prime is 0.12. I'm not going to write the units here. They're all consistent. 0.12 times 2.1 times sine 30 over 0.14 kilograms sine 46.9. And what you get is VB prime is 1.23 meters per second. And that is it.